Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us here today for the return of our CCNA Prep event series. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. Before we dive in, I wanted to take a brief moment to talk about the CCNA Prep program and also cover a few housekeeping items. For those joining for the first time, the CCNA Prep program provides valuable insights for throughout live sessions led by our subject matter experts. We're going to get to explore and dive into the latest exam topics. We'll have opportunities to test your knowledge, and we'll also share resources to help aid your exam learning experience. And speaking of those resources, we do have supplemental activity files for CML and Packet Tracer, which can be downloaded at any time. You don't need them to enjoy today's session, but they will be very useful for practicing on your own time. So we are going to be sharing those resources a little bit later on. So we've got you covered there. Also, if you're tuning in but have not officially registered for the prep program, I do encourage you to do so by scanning that QR code on your screen. This will ensure that you are notified of our upcoming events, access the resources, and you can also be informed of when these sessions become available on demand. Uh, Now, I just wanted to cover our Q&A and quiz questions poll for the event. So this will be an interactive session, and you can participate in our quiz questions via Slido. And that's also where you're going to be able to submit your questions and access resource links. So if you still need to log into Slido, please use the QR code that you see on your screen, or you can also log in directly through our live streams page on the Cisco Learning Network. And last but not least, at the end of this event, we are going to be launching a Slido survey, and we would really appreciate it if you can just share your feedback about today's session and let us know how we did. We always look forward to receiving your valuable feedback. All right, so without any further delay, I'd like to take a moment to introduce today's stars. So first, we have our presenter, lead content advocate Patrick Gargano, and he's also joined by principal engineer Hank Preston. Both are here to cover our topic for DHCP in action, streamlining network client address management. And with that said, I am now going to turn it over to our speakers to kick off the presentation for today. So, guys, if you're ready, please take it away.
Thanks, Rigo. Hey, Hank. Nice to see you again.
You too. They brought us back for season 2, right?
Season 2. And I
Some
thought
people said
we
it
needed
wasn't
to
going to happen.
make a moment of it, right?
Yeah. I mean, they liked us. Thank you to all of the audience that's joining us live, coming back in on demand after that. It's been fantastic kind of hearing all the feedback from all of you. We met a handful of folks actually in Melbourne at Cisco Live back in, I think it was December or November.
Yeah, that was cool.
And it's been great knowing that the CCNA community continues to be such a great and welcoming place. We're all in this together, and it's one of my favorite times is to hang out here online with you, Patrick, and just talk about some cool tech stuff, man.
And I really wanted to, create something cool to kick off season 2. And I found something kind of neat on YouTube, but some copyright issues there. So here's my homemade attempt at our theme music for season 2, Hank, if you're ready. Here we go. I'm going to just hum it, and then I'm going to go into it. So, welcome to season 2 of CCNA Prep. Join Hank and I as we continue the adventure by learning about network services in season 2. So DNS and DHCP and NAT and what else are we looking at? Syslog and SNMP. But yes, today we're kicking things off in episode 1 with a DHCP deep dive. Anyways, that was my attempt at a little jingle intro with my humming of a song. Hopefully, folks know and recognize as well.
Yeah, totally. Bravo on that. I think we need to work with production behind the scenes a little bit, see if we can get that like polished a little bit.
Yes,
right? We need to stick with the humming and just your performance on that. Maybe a little reverb.
We do like you could hum with me, right? And then you just keep going with the and I sorry. Anyways,
we'll workshop it. We'll see where we land. We'll see where we land on that. Awesome. Excellent. Well, we're back. Should we figure out who our audience is, where they're all coming from?
Yes.
Rigo, are you here? Can you help us out? Who's joining us today for episode 1 in season 2?
Yeah, absolutely. So I just had a look at our poll results here. So we want to know where in the world you're all at right now. So we've got USA. We've got a lot of folks from our neck of the woods. We've got Canada, we've got
Yeah,
Mexico, a lot of
nice.
fellow Californians as well. We got Brazil. We got Uganda. We got Chicago in the house. We got Houston.
Fantastic.
Yeah, Nebraska,
I'm
Romania. So
Yeah, I'm seeing some of my friends from South Africa. Some of you,
yes.
you might remember, I actually headed down for my first trip to South Africa last year to join some of the partners that are down there are working on the 525 program led by the NIL Africa team, and it was a wonderful time. So thank you everybody from South Africa. Right, starting here with the CCNA, and you're going to make your way up to the CCIE, and you've got the resources down there in South Africa to get you there. I have no doubt, man, no doubt.
Fantastic program. It's changing lives. I've read some of
Mhm.
the stories and listened to some of the interviews and not just heartwarming, but really touching how some of the people, the sacrifices they're making, right, to be part of that program and the value that it's bringing to their lives. It's very impressive stuff.
Fantastic. Oh, I see someone's from Ohio, really in my neck of the woods, right? So I don't know where in Ohio you're at, but welcome, right? It's cold, not as cold as last week, but it's still pretty cold here in Ohio.
It's cold. It's cold. Minus 27 here in Ottawa this morning. A little bit of snow, Celsius, obviously. And so I can appreciate the Ohio as well, cold there too.
Fantastic.
Awesome. So, yeah, Hank,
Take your
DHCP. So as I was saying, season 2 is all about network services. There's loads of those on the CCNA exam topics. So we're going to be looking at, as I said earlier, syslog and SNMP. We'll spend some time with SSH and NTP, but today we're having a look at DHCP, probably one of the most important ones. Like, who wants to assign a static IP address on thousands and thousands of devices on the network, right? You just want that to happen in the background, a server assigning IP addresses to all of the devices, your phone and your laptop and you name it.
Absolutely. All right. Well, let's let Rigo activate our next poll question in there as we kind of dive into the technology on this, because I know I, for one, have become really a fan of all things automation, and DHCP is such an old school technology, but it really was some of the earliest automation for IP address assignment. So help us understand, Patrick, how is this going to work for us?
So before we jump into DHCP and start looking at configuring it and how it works, what I'll do is I'll kind of quickly describe the topology, and we'll kind of investigate how the network is currently working. Because at the end of the day, before you deploy DHCP, everything else needs to be working, right? Your IP addressing, your static IP addressing on your routers needs to be configured. Your routing protocol needs to be configured, right? You want connectivity, you want end-to-end connectivity, so that when you start requesting those DHCP addresses for your different clients, something's actually going to happen. So we'll have a look at that. And then I want to go through basically 3 different configuration steps or tasks here. One, on this router at the top right, we're going to configure that one as a DHCP client. And the idea that I had here was to kind of simulate what you folks at home have with your internet service provider and your router at home or at a branch location. So you've got a device connected to the internet. It's got to get an IP address. Usually it'll get that from the service provider, and usually it'll be assigned dynamically. I mean, some of you might be paying for a static IP address, but most of the time it'll be DHCP. So that'll be one of the tasks, and that's part of the exam blueprint as well. And then the second and third kind of go hand in hand. We're then going to configure RTR1, this router over here, as a DHCP server. And it's going to be providing IP addressing to 2 LANs. So the LAN at the bottom left here, the 192.168.1.0 LAN, and the one over here, the 192.168.2.0 LAN. And there's a big difference between the two, right, Hank? One is local, right? This LAN on the left is connected right into that router. And so it'll be able to, give out those IP addresses. But this one on the right, this far away LAN, is a remote LAN for that router. So we're gonna have to deploy a little bit of magic there, right? So for that to work. But anyway, so I think that's where we're going here today.
Fantastic. All right. Well, where do we want to start? We're going to try to get the internets up and working.
Yeah. Like I said, I just want to have a quick look at how the router is actually configured on both sides here. So as you can see, router 1 has a couple of IP addresses, one on the LAN connection, one on I was going to say the WAN connection. It's not really a WAN connection, but on the other connection to RTR2. And it's the same thing for RTR2, right? So they only have those addresses configured. If I do a quick show IP route, we can see that I do have OSPF running, and I drew a big green rectangle around there so that it was pretty obvious. I just put everything in area 0, just kept it as simple as possible. And you can see both RTR1 and RTR2, or router 1 and router 2, are getting just one OSPF network being advertised through to them. So, router 1 is learning that 2.0 network, which is over here on the right, and RTR2 is getting this 1.0 network. That's the one on the left. So
they're
that's
just
it.
sharing their local branches, right? So if the idea here is,
exactly. So I've got connectivity from side to side, through the network over here. But anyway, so that was just like the baseline quickly of how the network is operating. And if I come back to this router, as you saw, if I do a show IP interface brief again, you can see that the E0/3 interface isn't assigned an address right now. It's actually shut down. And so what we want to do is start configuring that interface so that it acts as a DHCP client. It's really, really straightforward, very simple command. We're going to go on to the interface. And Hank, do you remember what this command is? Put you on the spot.
Well, I mean, we're talking about IP addressing. So I'd start with IP address.
Yep.
And then normally, if it was static, we would provide the IP address and then the subnet mask, but we don't want that. We want it automatic. So I think we can just say DHCP here to indicate we're going to receive that from DHCP.
Easy peasy, right? So
absolutely.
That's it. I need to turn on the interface, obviously, at this point. So that's the only command I need to enter. And obviously, a bunch of stuff is going to happen here. And this is what's really cool with CML. You can see that I've connected it to one of those external connector nodes, which is doing some sort of a NAT on my local device. Well, not on my local device, on the server locally in our data center, to emulate and to act as if there was a service provider there. And you can see I wrote on the diagram here, DNS 8.8.8.8, the Google classic one. So it's not in our CML. I'm just reminding you that there's a server out there and we'll be using that. But I think, Hank, I do want to bring you back when we talk about DNS in a minute. You've got a suggestion about that as well, I think, to look at.
Yeah.
While I've been talking, magic has happened, right? The interfaces come up at layer 1, interfaces come up at layer 2. And then we've got this DHCP message saying that an IP address has been assigned to the interface. The IP address is 192.168.255.32 with a /24 subnet mask. If I pull up that show IP interface brief command, you can see a bit of a different output now, right? So we've got our IP address. And the method
I do like this.
DHCP.
And there's an interesting in here. Yeah, the method showing DHCP is always kind of the key to where it came from. And here's one. I don't know if you know this, Patrick, putting you back on the spot. And normally I would have looked this up, but I just noticed it because you just get so used to seeing things over and over and over again.
Yeah.
Those static IPs are method TFTP. Now I know what TFTP is, but we clearly didn't use that for those. And this is just kind of one of those interesting, probably side effects of like the 30+ year age of iOS. But any idea on why those are referred to as TFTP as the method?
It's bizarre, eh? Obviously, when these routers booted up, they had a startup config, and it copied that into, from NVRAM into RAM, and then enabled the interfaces. And I to be honest, I think I've never seen anything else written there, like NVRAM or anything like that. So I think it's just that process of copying it over. But good question. Maybe someone in the chat would have the answer.
We'll see if anybody knows. Otherwise, I may actually dig into that a little bit with some of the iOS developers that have been around a little bit longer to see if I can figure that out. Maybe we'll hear back on that in a later one that's there.
It's one of those that's, as you said, I've always seen that, and
you're just so used to it. So DHCP gave us an IP address, which is awesome, right?
Yes.
So 192.168.255.32. But in order to reach the internet and be functional, we need more than just an IP address. So what else did DHCP deliver to RTR2?
Thank you. So if I have a look at my routing table, some other stuff has happened. Obviously, the interface has come up, so we've got a couple of lines for that interface and its IP address. But this is the bit here that I want to kind of focus on for a second. So a little bit like you, when you configure an IP address a DHCP IP address for your laptop at home, you get an IP address, a subnet mask, and you get a default gateway. And something similar has happened here for RTR2, right? It's got its quote unquote default gateway. We would call it a gateway of last resort or a default route. So, and interestingly enough, it's assigned it to the routing table as a static route as well with an S*. So a static default route. It has a really high admin distance. So it's not the most trustworthy information is what we kind of glean from that, right? If you remember, admin distance, a smaller value is more trustworthy. And then obviously we have next hop information as well. The one thing I forgot to pull up earlier that I did want to mention in my OSPF configuration, I did do something a little advanced. It's a little CCNP level, but notice that last line in the OSPF config, default information originate. Now, this command is quite interesting. What it does is it allows OSPF to advertise a default route in the OSPF process, if you like. But there's a gotcha there, Hank. What's the gotcha with that command?
Oh, geez. I'm sure there's a bunch of gotchas. I'm trying to think of which one you're thinking of there. I mean, the router has to know where the route comes from. Is that what you're referring to? It has to know, it has to have a route in order to send it out, right?
Exactly. So, and I wanted to show it earlier, and I skipped it. It's described in the lab, but a few minutes ago, the router didn't have that static default route, right? It just learned it a few seconds ago. And so this default information originate command is telling OSPF, okay, go have a look at the routing table. If there's a default route, grab it and now advertise it through OSPF to your other OSPF neighbors. And this is where we can come back to the router on the left and do a show IP route, and we can actually see that that's what's happened. We have an entry at the top here, O*E2. Again, a little bit advanced, but that's basically saying that it's learned this external default route through OSPF, and it's learned it from its neighbor RTR2. And we can see, right, admin distance of 110 and a cost of 1 to get to it.
Yeah, I want to hone in a little bit on something that you kind of talked through, Patrick. On RTR2, can you scroll up just a little bit so we can see that full kind of routing table, including the default? Yeah. So as you pointed out, right, the DHCP provided a static route, and the static route to the default gateway, and it set the admin distance at 254, right? So for the chat, everybody watching that's in there, right, we're back into season 2, but we talked about static routes in season 1, and that's a fundamental topic. And so what is the standard admin distance for a static route? So I'll give it a second for the chat to kind of think through it. Ask yourself, consider this like a practice for a CCNA multiple choice question. Like, it's a classic one. What is the admin distance for a static route? So as you're thinking through, hopefully you've thought about it. All right, we've buried the lead enough. Patrick, what would the admin distance be for an actual static default route?
It'd be 1, right? The default value is 1 for a static route. It's supposed to be super trustworthy because, well, it's a static route. It's a network administrator that's typed it in. They should know what they're doing, basically.
Exactly.
That's not the case here.
It's not, because what we're getting with DHCP is it's an automatically delivered option for a static route, for a default route that goes in here. And I actually kind of like the idea of gateway of last resort. You can think about that from a DHCP perspective. So DHCP provided the last possible resort for a default gateway for this router. If R2 had a default route that it learned through a static route, it would prefer that because an admin distance of 1.
Exactly.
If it had learned a default route from OSPF, the admin distance would be 110, like we see on RTR2. Exactly. So it would prefer that and ignore the default route that came in from DHCP. Only because no other source of a default route has been provided, that's why the DHCP one is here. Because as your point, right, Patrick, this is a router. The idea here is that any other source of a default route should be preferred over something that might be learned from a DHCP server that's in here. This is mostly relevant for kind of an actual kind of enterprise grade router that might have multiple networks and multiple sources that are in there. But the same basic structure happens when you connect your home wireless router or your kind of your broadband provided wireless router and access point out to the internet, right? It's going to get a default route that comes in, and it kind of works the same process. That's how your system knows how to get to the internet, is because it gets an IP address, it gets a default route. Now, is this the time where we start talking about some of the other things that DHCP provides, like that DNS element, Patrick?
Soon, Hank. Soon.
Okay,
we're getting there. I just want to show a little bit of connectivity testing. So as you can see, while Hank was talking, I did a quick ping to that Google DNS server, just to show you that we do have actually connectivity out to the internet, right? I pinged 8888 and it is working. In other words, the ping is going from RTR1 to RTR2, RTR2. And again, it's going from RTR1 to RTR2 because of its default gateway. Then RTR2 is taking that traffic and throwing it out to 192.168.255.1, right? So it's going out that way because of its default gateway or default route. And it's then hitting that external node, going through our internal network at the data center and then getting access to the internet that way. So we do have full connectivity thanks to this IP address that we got for our router 2 kind of internet facing interface. Rigo, I think the question I was asking in chat is about this, what just happened here, or not in the chat, but in the Slido poll. So are we on the second? Yes, we are. Okay.
Yeah.
Let's have a look at it, please.
Okay, sure. All right, so we got, so which of the following commands configures a router's interface to act as a DHCP client? So out of the 4 options, we've got IP address DHCP taking the top spot with close to 80% on the vote. And the other 3 are actually trailing behind. That is, in fact, the correct answer.
Yes.
But Patrick, Hanko, do you guys have any comments on how our audience did?
No,
they did great. Well done.
Yeah, exactly. You've been listening. You know your stuff. And again, if I don't know if you're able to see, it's quite small, but on the left here on the CML topology, we did grab the CCNA exam topics, right, to just drop them in there. And you do see that the 4.6 is all about configuring and verifying a DHCP client. And so this is what we're doing, right? We've configured the client and we're able to access the internet here. So just make sure that you're familiar with those concepts. Cool.
Awesome.
I think we can put up the next question, Rico, and we're going to go to the next part of the lab where we're going to come back to router 1 and start configuring it as a DHCP server locally, right, for the 2 LANs in the green box. So we're going to do a DHCP pool or configure a DHCP server functionality for the left LAN first, right? So the 192.168.1.0, and then we'll do the second one after that. So here we go. There's a couple of things here. When you configure a DHCP pool, one of the things that you typically want to do also is exclude addresses from that pool, right, Hank? And this is, why would we do that?
Oh, I mean, it's a great question, because the idea here is when you create DHCP on a network, in this case, let's say the local area network for PC1 that's off Ethernet 01, the majority of hosts on there, assuming this is like a campus network with clients on it, are probably going to get their IP addresses from DHCP. But I can almost guarantee there's going to be at least a couple of devices that get statically assigned IP addresses.
Yes.
And you don't want to accidentally end up with duplicate IP addresses with DHCP assigning an address that's also been statically assigned someplace else. So the one definite static IP address that comes through is the router itself, right? Yeah. Whatever device is going to act as the default gateway for the network will undoubtedly be configured in a static fashion. In this case, it's router 1 itself. And so we need to exclude that IP address. But there could be other types of hosts on that network that you don't want DHCP to go for. Some common examples might be printers, right? Back in some of my early days as a network engineer, I did a lot of kind of work at different offices where we'd install printers or fax machines or scanners. And those typically would get static IPs, and they may be on the same network that the PCs are. So we need to exclude a chunk of IPs for use there. There might be services that are out there, things like a DNS server potentially, or other resources. And so we exclude addresses so that we say these ones here, we're not going to provide that automatically. Everything else that we don't exclude would be provided automatically.
And I guess a sneaky exam question could be, right, if I show you this command, IP DHCP excluded address, 192.168.1.1 space 192.168.1.5, am I just excluding those 2 addresses? And no, actually, you're not. You're excluding, that's a range. It's from 1.1 to 1.5, right? You could see when I did a question mark, it said, what's the high IP address? You might be wondering why I started with that before configuring the pool. I mean, it's just a habit of mine. I like to do the excluded addresses first, because what can happen is as you're configuring the pool, as soon as you do pretty much like two commands, it will start giving out addresses. And if you're not quick enough, it might accidentally give out an address that's been assigned statically to something else. So it's just, I don't know about you, Hank. That was my tip of the day. Always start with your excluded addresses first.
Yeah, I think that's good behavior for almost anything. DHCP for sure, but there's other types of configurations you do where putting the exclusions in, right? The exceptions are always better before turning a service on because 100%. Of that, and you can run into those types of issues. Now, as you're working through some of the configuration here and we dive deeper, one thing I do want to point out, and we're going to see this not just in today's episode in season 2, but we're going to see this in a handful of the episodes where we cover different IP services this season. The blueprint for CCNA only asks for, and Patrick's got it here on the CML topology, configure and verify DHCP client and relay. We've done client, we're going to do relay shortly.
Yeah.
But what we're running through now, how to configure a DHCP server on the router, isn't technically on the blueprint.
Good point.
But it is a great feature to understand and kind of have some experience on to help you with 4.3, explaining the role of DHCP within a network, as well as practice these skill sets. And so you're going to see this today, as well as kind of for the rest of the season, where we kind of go a little bit beyond specifically what's on the blueprint to help you further understand kind of what these services are used for and how they work. And so kind of stay tuned for that all season long, where we're going to dive into configuration of things so that we can better explain their role or understand their role.
Yeah. So the first thing I had to do at this point was create what we call a DHCP pool, and that's going to be enabling the server functionality, DHCP server functionality. And I have to give it a name. I like to give it a name that kind of describes what the heck I'm doing here. So this is the pool for the RTR1 LAN, right? The router 1 LAN. So I can start with that. Now, if you want to be a little bit intimidated, you could do a question mark here and see that there's a huge list of subcommands of options that you can enable when you're configuring DHCP. You don't need to know all of them, right? We'll hit the important ones today, and there's some that you need absolutely to configure, and then we'll start with those. And then the other ones are kind of optional in the sense that even if you don't put them in, your server will still hand out addresses, and your PCs will get them, and you should have connectivity at that point. So the first one I'd like to do is deploy and configure the actual network that this pool will service. And we know what the network is, right? 192.168.1.0. I just want to do a little question mark here because there's two ways of specifying and configuring the mask. I could type out the mask, right? Like 255.255.255.0, or I can do this cool thing, which I like to do here because we can't, not very often, right, Hank, can we actually use the slash or the cider format for the mask. So I like
not
using
in iOS
because I can.
Yeah, in iOS, there's only a few spots. Some of the other network platforms like Nexus OS, which is used in the data center, and XR, which is more of a service provider, where the cider notation comes in. But with classic iOS, yeah, we're pretty much kind of spelling out and typing out the full subnet masks.
So that first command was really important. It's the command that's basically saying, okay, this pool is responsible and will be handing out addresses from within this /24 network. So that was an important one, right? Nothing else is going to happen if we don't have that command in place. And then the next important one would be the address that's going to be assigned as the default gateway to the PCs and the clients. The command is called default router. So be careful about that. You can almost see an exam question around that as well. So that's the address. And so I guess that's a good question. Where is that address? If I ask you quickly, right? If I'm looking at this topology, Hank, where is that address in this network? That 1.1 address?
Yeah, so I like this. So looking at this, the idea, it's the default router. It's the router that allows PC1 to reach other networks. And so that would be router 1. And what interface on router 1 is connected to PC1? Ethernet 01. So that's where we would find that IP address configured.
Yeah. And I think if I scroll up, we'll see it because I remember I did a show IP interface brief at the beginning.
Yeah.
Yep, here we go. There it is. Yeah. So 0/1 is that interface. 192.168.1.1 is the address that we needed. So
yeah, absolutely.
At a minimum, I think, Hank, right? That's all I would, at a minimum, that's all I would need to get this up and running. But there's a few other options that I think we can deploy here while we're at it. And one I think you wanted to talk about a little bit, which was
DNS.
There we go. So in the lab documentation, the DNS server that I was going to use was 8888. But Hank, I think we had a chat about it, and you had made a really interesting suggestion. But specifically with CML, folks, if you're using the packet tracer, you'll have to use the fake simulated 8.8.8.8 server that I have in there. But here we've got another option. You said, I think.
I do, yeah. So CML itself, that little cloud that you've got in there that's labeled as internet, right? Yeah. That represents the CML network itself, and it provides a bunch of different services to allow hosts to kind of get out to the internet and the other components that are in there. And you can actually use it as the DNS server in these topologies as well. So within CML, we could use DNS server of 192.168. 255.1, and that is the CML server itself, right? And that's the address that was issued to router 2 through DHCP, if you remember. So it can actually act as our DNS server in addition. So
it's like the gateway of last resort, right? So all of these things are running on that device. So I'm going to believe Hank. So we'll go with that, and maybe for the second pool, I'll put the 8.8.8.8 address instead, just to show you a little variety there as well. What else can we have here? Oh, domain name, right? Here's another popular one that, again, it's optional, but it's always a handy one to add as well. So Hank, you suggested that I use lab.example, I think, if I remember correctly.
Example.com.
Example.com. There we go.
Yeah.
Fantastic. So domain name for the company network. And then the last one that typically I would like to do is specify the lease time. Again, it's optional, but I can specify it. For example, I could say 0:12, and that'll be 12 hours that it would be leased. In other words, it would refresh the address every 12 hours, for example. But again, I can adjust these values if I want. Anything else that you typically would configure, Hank, in DHCP?
No, I think you've hit the basics that are in here. And so a couple of pieces I want to hone in on this, right? So we're going to dive deeper into DNS in our next season 2 episode, which is actually going to be CCNA Prep Live from Cisco Live. Patrick and I are headed off to Amsterdam in a couple of weeks, so stay tuned for that one. So we'll dive deeper into the DNS side. On the lease side, I think that's another one, and it's going to give us an opportunity to kind of talk through some of the questions the chat's been asking us. So while you go through, go ahead and you can start. You'll do some show, so we'll wait on it. But what the lease command does, as you mentioned, it basically says when a DHCP server hands out an IP address to a client, this is how long that's good for until the client has to come back and say, hey, can I have it for more? Right? Can I continue the lease on this? And usually clients will ask before a lease runs out so that it doesn't lose IP or change IP unnecessarily. And so that kind of factors into one of the questions that we came through. So Richard in our chat asked, hey, if a PC in VLAN A with DHCP gets moved to a new port over in VLAN B, how does the IP change for this new subnet, right? How does it function?
Right.
And so the lease is a good way to kind of talk through this, because some of the question answers depends on how the PC moved. So we'll go with the easiest one. So let's say you actually unplug the computer from the switch port and then you plug it into a new port, right? In that case, the PC is going to recognize that its interface went down and then kind of clear out its DHCP assigned address. And then as soon as it plugs back in, it's going to rerun the DHCP process to get an address from whatever DHCP server replies, in that case in VLAN B. Now, if we didn't unplug it, if we just reconfigured the access port to point at VLAN B, the switch or the host doesn't know that the interface changed. So in this case, this is where you can have actually an outage. And what would happen is if nothing is done, eventually that lease will run out on the address and the host would go out and ask to renew it. Now that renew would fail because it's now on a new network, and then it would get a new address on VLAN B. And so that's actually kind of a key aspect. If you are moving hosts from one VLAN to another, to minimize disruption for DHCP addresses is either unplug them or shut the interfaces so that the client will rerun through DHCP that's there. Anything to add on that? Anything other aspects?
Just thinking of IP config or if config commands where you could release and renew an address as well
on a client.
And
that's
so
assuming your hands are on the client, though. These were kind of from a network engineer's perspective. But yeah, you can, if you're standing at the client, kind of force those release and renew pieces. And then the other one, there's a couple of questions that came in here from Brad that kind of dive in that I want to hit as we're kind of talking through this. So you're configuring the DHCP pool on the router, right? An iOS-based router. And so one of the questions was, what's the difference between a router and a managed switch? And so there's a big piece that goes into those. So we'll start with router versus switch, right? Router is connected to multiple layer 3 networks and can route traffic from one network to another. A switch provides access to a single network that's in there from a layer 2 perspective. So that's the biggest difference between router and switch. The use of managed, we focus in on managed just means that it's something that you can actually configure. The difference here being if you go to your local home electronics store because you need more switch ports right at your home to plug your TV and your smart devices and all these things into, those are considered unmanaged. There's no real configuration you can do on those. But like an enterprise switch, a Cisco switch, where you can go in and create VLANs and program them, that would make it managed. Now, there's another type of switch called a multi-layer or layer 3 switch, which kind of acts like a switch in a router. And in that case, to your another question, Brad, you asked, can a managed switch be a DHCP server? If that managed switch is a layer 3 switch, which makes it kind of multi-protocol, then yes, pretty much the exact same commands that we're running here on router 1 could be done on a layer 3 switch to create the pools on that side. So it really just needs kind of layer 3 functionality in order to do the DHCP side. So hopefully that helps, Brad, on those couple of questions that are there. And so I'll hand it back to Patrick. Let's dive through on this because I'm excited to see DHCP in action here for our PCs.
Yeah, for sure. So I hopefully I didn't point it out at the beginning, but you probably all have noticed by now in my CML that PC1 and PC2 have that little X icon on it. It's because they're currently off. I did that on purpose. I left them off because I wanted to do all of this config stuff and then turn the PCs on so that they would pull and request an address from the server when we were ready, and which we are, and we'll do that in just a second. So this show IP DHCP pool command is quite handy. Allows you to see what's going on with this particular pool, how many addresses there are within that pool, how many are excluded, if any are leased. Well, you can see none are leased right now. The server would be happy to respond if a request came in, but no requests have come in yet. And again, you can kind of see what the range is, right? From 1.1 all the way to 1.254. So a really, really handy command to just kind of check to see the status of your pool. Before I turn on the PC, I'm going to turn on a couple of debugging commands on the router. They're going to generate quite a lot of output, and I'll just kind of highlight the kind of key ones because I think one of the classic, exam questions and topics that you really, really want to understand around DHCP are those 4 DHCP steps. Hank, while I turn on these debuggings, can you run through for me the 4 DHCP steps, please?
Oh, absolutely. So the first thing that's going to happen is when the PC comes up, it's going to go out and attempt to discover DHCP servers. And so it's going to go through and say, okay, hey, are there any DHCP servers? And sends that out as a broadcast. And then once the DHCP servers get those, it will send out what's referred to as an offer, right? So we get a DHCP offer, and the DHCP server will say, here is an address that you can have. The client will then receive that offer and then decide, sure, I want that offer. And it will send a DHCP request saying, yes, I'm requesting that you assign me this address. And then the final of the 4 step is an acknowledgement by the DHCP server saying, yes, you have indeed been assigned this address. You can begin using it. And those 4 steps are really important. The first one makes sense, right? But why are the other ones so critical? Why such kind of back and forth before we just say, sure, you've given me address, I'm going to use it? And it's to make sure that we're very clear on record keeping in the network. Yeah. You could have more than one DHCP server out there that provides addresses. And so we don't want to have 2 different servers mark addresses in use, and only one of them is really in use. And then we also want to make sure that before the client kind of says, I'm going to use this address and begin using it, that the DHCP server has marked and said, okay, I've permanently assigned that, or at least for the lease, assigned that to you. I'm not going to give it to anybody else. So we really want to make sure that we're super sure about kind of where these addresses are assigned, because duplicate IP addresses can be a real challenge in a network and sometimes hard to track down.
And I think the key thing that I'd like to remember around DHCP with those 4 steps, Hank, that you were talking about is DORA, right? DORA. I remember when Sam, my son, was quite young, he would watch Dora the Explorer. And so it just kind of sunk into my head. So yeah, discover, offer, request, and acknowledgement. So those are the 4 messages that you want to get your mind kind of wrapped around, or your head wrapped around as you're studying for this. As Hank was explaining that, I turned on those 2 debugging commands I mentioned earlier. Let me scroll back up just to show them to you again. As you can see, I did promise there'd be a lot of output, and so this comes from these 2 commands. So debug IP DHCP server events, and the other one was debug IP DHCP server packet. You could turn on just one if you wanted to kind of limit the output a little bit, but what I wanted to do is just kind of, I just mentioned the DORA, right? DORA, and I just wanted to have all this output just to kind of highlight them as they were coming into that PC. So I turned on the PC, and that's why we got all of this debugging output. So as I scroll down, you can see we already got that DHCP discover message, right? So that was the first of 4 DHCP messages. Message received from a client on a specific interface on the router. And if I keep going down, I should be able to find the DHCP offer. A lot of messages. Discover again. Here we go. Sending an offer. So here we go. So it's offering the 1.6 address, which Hank, right? That makes sense because we had excluded 1.1 to 1.5. So that was step 2. Then I should have the request. Here it is, DHCP request received from the client again. So just to come back to what Hank was saying, really, really, really important point, right? So if there are multiple servers saying, hey, use me, here's an address for me, here's an address for me, I need to send this message saying, I want to deal with this server and I want that address, right? I want to lock in on that particular device. So that's what that third message is all about. And then we've got the acknowledgement, which should be coming along somewhere down here. Did I miss it? There it is, sending DHCP ACK to client. So it's acknowledging that this address has been assigned to the client. This is looking good. Let's have a look at the client itself. Let me go to the console and have a look at the IP address that it received. I think it's Cisco, if I remember correctly. Yeah, there we go. Now, Hank, I'm glad we had a chat about this the other day. I was using the old Linux commands. Hank was like, Patrick, I'm disappointed. No. He was like, there's some new kind of updated commands for this to have a look at what's going on the PC, because these are Linux devices. So I promised Hank I would use those. So here we go. So IP address. Basically, what I'm doing here is I want to pull the IP address information on this client and have a look to see what it did in fact receive, right? So IP address, I want to show dev, and I know that it's Ethernet 0 on this particular device. It's a bit of a funny sounding command, Hank, to be honest with you. I'm not a huge fan of it. Anyways, I'll just...
Would you prefer show IP address? I mean, would that make you feel better?
Yes, I would, maybe. What do we have here? So I can see that I've got that 1.6 address that I promised. The output was showing on the router earlier in the /24, right? So it did in fact receive its IPv4 address. And the other command, and is there something else you wanted to mention this? I was just going to pull the
no, go for it.
The route list here as well while we have it. So there we go. So the full picture, we can see that we have a default gateway / default route, whatever you want to call it. In this case, default gateway, since it's a PC, and it's the 1.1 address that we know is configured on RTR1.
Yeah. So there was something else that we configured in here, and there's actually a question that's come in that we can tackle on this. So in addition to the IP address, the default route, right, we also assigned some DNS specific things. Now we're going to go super deep into what DNS does and why it's important. But since it's in here and it does tie in with DHCP, and we had a question from it looks like Oisin about why DNS and domain names are important for DHCP. Isn't it just about IP addresses not resolving? And the key part why it's important is because your general clients don't want to memorize the IP addresses for every single thing that's out in the world and connected to their computer. So having DNS is really important. And so it makes things like web browsing and all application services work. And DHCP is the way to dynamically issue those to the clients. And Patrick's shown here that indeed we can use DNS lookups because it received those. Can you show what the DNS server was assigned through DHCP? Do you know how to display that on the Linux machine?
I don't, so I'm glad you're here.
Yeah, it should be. I don't know. I'm pretty sure in Alpine, which is what this is. But if you do a cat space /Etsy space /resolve tab, so etc/ and then /resolve, and then just tab it out. I don't think there's an E. I think it just ends in V. Tab, there you go, and enter. It should have populated. Yeah, it did.
Hey,
and so
Hank to the rescue.
DHCP provided the DNS information, both the name server and the search string that's in there. Now, I don't want to go super deep on DNS because we still got a lot of DHCP stuff to go here. So use this as a teaser to come back in 2 weeks and catch our DNS episode where we'll go detailed into these name servers and search stuff on that side as well.
You've got to come back for part 2. Well, not part 2, episode 2. There we go.
Episode 2, absolutely. So we'll nab into that. All right. So I think, are we ready to jump into, because boy, we knew DHCP. We weren't going to have to go super deep, but we're already 45 minutes in. So let's make sure we get through the key aspects.
Yeah, just to finish with this one. So as you can see, it's able to ping 8.8.8, so it's just an address on the internet. And then as Hank was saying, I pinged Cisco.com. Clearly something happened, right? A DNS lookup happened to that CML DNS service that we're pointing to, that 255.1. It resolved it, found out that the address for Cisco.com was 23.60.70.119, and the ping worked for there as well. So this is looking fantastic. So yeah, let's go to the last part, which is configuring the second DHCP pool for the other LAN. And And we're going to encounter a bit of a problem or a situation where when I turn on the client, it's not going to get the address immediately from that pool because it's not directly connected. And so we'll have to talk through that a little bit when we talk about DHCP relay. So let me just turn off the debugging. Oh, typo there. And it's basically the same steps that we just talked about. So I'm going to do an IP. I think I've got the commands. Let me grab my notepad. It'll be a little faster since we're running short on time here. So bear with me. So I'll do a conf t.
Yep. So you're applying the second pool here, right?
I am.
All right. So you paste that in because I'm going to hit some of these really good questions. The chat's been burning up over here with great ones to go in. And so you apply it while I kind of hit some of the context. So one Kumar asked, can the router behave as the DHCP server on any interface or for the DHCP? And the way that this works is the router is going to act as the DHCP server for its local interfaces for pools that are assigned. But what we're seeing Patrick do now is he's actually creating a pool for a subnet that's not locally attached. So we're going to see kind of how the relay service provides the ability for centralized DHCP service in an overall network. So we're going to see that in a second. And then there was a couple other questions in here. It looks like Saad had a question. Is using a router for DHCP the same as using a server for a large network? If you're in a large enterprise, typically you would have a dedicated server, either running based on a Linux or a Windows system. A Cisco router can act as a DHCP server, does a fine job. But I would say if you're anything outside of a small or a medium branch, like a dedicated DHCP server is typically used on those sides.
So I've configured this second pool, as you can see. I called it RTR2 LAN. It's for the 192.168.2.0/24 network, which is not a network that belongs to RTR1, right? It belongs to RTR2 or router 2. So although I'm not directly connected to it, I've created a scope. I've created a DHCP pool for that network. I've given it the default gateway address, default router address 2.1, which is the IP address on the E0/1 interface way over here, right? So let me grab my arrow. I'm talking about this interface over here on RTR2. I've given it the DNS server of 8.8.8.8, as I said I would. Got a different domain name here. I forgot to put the .com at the end. So lab.example, same kind of lease. And I excluded those addresses again, the first 5, right? So from 2.1 all the way to 2.5. I turned on all that debugging again, just to have that running in the background. And what I'm going to do, I'm going to just turn on this PC and just going to wait a few seconds, and well, nothing should happen is the answer here. And it's not because something's broken, but so what's happening is the PC2 is booting up and it's configured for DHCP. And so it's sending out a message. And Hank, did you mention earlier, so that discover message, what kind of message is that that it sends out?
Yeah, those are broadcast messages, and broadcasts stay to the one local LAN that's in place. It doesn't extend out. Right?
So while we're waiting for that, I forgot, maybe Rigo, could you come back to us with the next poll question? Because I think the question was around one of the configuration commands for DHCP.
Yeah, absolutely. So the question was, which DHCP server configuration command specifies the address of the default gateway? And the standout choice that I see here is IP default gateway with 52%, but default router closed in at about 45. How do you guys think our audience did here?
I'm not surprised.
Yeah.
I think that the move up of default router came kind of probably shortly after we hit that point in the presentation, which is okay, right? These sessions are all about helping people better understand the technology. So use it for that, right? Learn from our sessions that are in there. But it's one of those, again, we've talked a lot about how questions on the CCNA exam are definitely not intended to be tricky, but sometimes things can be a little bit, maybe not as intuitive as you might expect. So a question like, how do you specify the default gateway? Right? If you don't have the experience, if you don't have the muscle memory of typing these things, you may just assume, hey, IP default gateway sounds reasonable, but in fact, default router is the right answer this time.
Very good. Very good. And as we've been chatting, as you can see, router 1 has never received any DHCP requests. So just to come back to what Hank was saying a few seconds ago, the idea with these DHCP messages, especially that first one, that discover message, is a broadcast, right? So it's going to hit everything within the 2.0 network. It's going to hit the router on that interface E0/1, and it's going to stop there, right? The broadcast isn't allowed outside of that local area network. So we need to come to the PC's rescue, basically. We need to do something on the router to basically say, hey, when you get a broadcast message, kind of like a DHCP message, on this interface, the E0/1 interface, when you get a broadcast there, instead of dropping it, can you convert it? Can you flip it into a unicast message and send it somewhere? And in our case, that somewhere will be the router 1 device, which is ready to respond to those messages. So it'll be a broadcast, right? That'll hit router 2, a unicast to router 1, a unicast back to router 2, right? Because it's DORA, so discover, offer. Then the request will come in again as a broadcast. That's going to be converted again as a unicast, and responded back again, back the other way with the acknowledgement. So that's all that's happening there. And we're going to try to capture that, I think, on the link in CML when we get this going here. So hopefully this is making sense, right, Hank? So we're going to configure this command on router 2.
Yeah, absolutely.
And
do you have, before you configure, let's get the packet captures running on that link so that we can actually see them go through.
Sounds good. So interface E0/1. And so I'm just checking, which poll question do we have up right now? Is that the question about the
we've activated 4. I had Rigo do that while we dove back in.
Fantastic. Yeah, I kind of already given quite a bit of a good answer, I think, to help folks with that particular one. But okay, so before I deploy this, you're saying we should enable the capture, right? So we'll do a packet capture on the link between the routers. And the reason I'm doing it here is because I want to see those DHCP messages kind of popping out of the local area network and being sent to router 1, right? We're going to do a packet capture. And I think you'd suggested to me we can filter that, right, with DHCP messages.
You can just do the drop down. We actually have DHCP as one of the pre-built templates in CML. So over there on the left.
Ah, the template. Thank you. Yep.
Yeah, just pick DHCP there at the top.
Oh, there it is. Thank you.
And apply.
Apply that.
And this will make sure we don't see all the noise from CDP and spanning tree. Well, I guess spanning tree would be between the routers, but all the other stuff that's running. So.
And we'll come back here. So the command is a funny sounding command. What's frustrating with this command is because the concept is called the DHCP relay, but that has nothing to do with the syntax of the command itself, right, Hank?
That's correct. And I don't know for sure, but I have a guess as to why we have it like this. But tell everybody what our command is.
Yes, IP helper address. And I'm going to specify an address, the address that I want router 2 to send these messages to, right? I want to send them to router 1 here. So in this case, I think it'll be 10.1.1.2. Let me just confirm that. Make sure.
Router 1. I think it's router. I think it's .1. Yeah.
10.1.1.1. So there we go. So as simple as that. That's going to allow me to send these broadcast messages that are received on that interface to the 10.1.1.1 address. I don't know if you notice, we received a bunch of messages on the left here, right? Because I had the debugging going. I can see that these messages are like we've been looking at earlier, the DORA messages, and it seems to be doing something for the 2 dot network, right? So that's making sense. Did I capture anything interesting here?
Why didn't they come in? I would have expected them as well.
What I could maybe do is let me stop this device again.
Yeah.
Give it a sec, and then I'll start this again, and I'll start the device again. We'll see if that helps. So I've just rebooted the PC just to kind of force the request, the DHCP request to come through the link.
There we go.
Hey, fantastic. I'll maybe make this a touch bigger so we can see what's going on here, because there should be 4 messages. Let me stop the capture. And listen, I'm so impressed with CML. I gotta say. You could do this also, by the way, if you've got a little home lab going, you could do this with Wireshark, right? With some real devices, you could capture this traffic as well. Packet Tracer has some cool packet simulation and capturing features built into Packet Tracer. Really like how smooth and simple this was with CML. And look how clear this is, folks, right? We've got the 4 messages: DORA, discover, offer, request, and acknowledgement. And you can see the source and the destination in each case, right? The source coming from the interface on router 2, and it's going to the destination, which was right. These are the messages that are being forwarded as unicast messages between them. Something you want to dive into this one here, Hank?
Well, I would dive into DHCP probably for another 4 hours, but unfortunately, we've got about 4 more minutes left in this session. So a couple of things to point out in the capture. We talked about how the messages from the hosts are broadcast, but we can see them translated to unicast here. And so there was a question that came in, hey, can I get the lab access? That's all available as part of CCNA Prep resources, and you can go through this on your own using CML, or as Patrick mentioned, we also provide it for Packet Tracer. And I encourage you, as you're exploring and practicing DHCP skills on your own, do a packet capture on the interface from the host and compare that to what we see between the routers, so you can actually see the differences that are in there. So lots of room for exploration for you to kind of dive into this and kind of see how it goes in further. But I do think we probably need to finish up. We got a couple of questions that I've been holding in the kitty for the end. And then I think we may have at least one more poll that we want to bring Rigo back and talk in. So any final demo pieces here before we hit our hour limit?
I just want to show folks that it's working.
Let's see.
So let me just jump onto PC2, which now has an IP address.
Yep.
And I should be able to ping that same destination that we were pinging earlier. I should be able to ping, a lot of typos here. There we go, cisco.com. And that's working too. And obviously I can pull up the same questions that I was using earlier for having a look at the IP address on the specific device. So show dev eth 0. All right, so it's received, or maybe I didn't type that properly.
What you did?
IP address show dev ethernet 0.
Oh, you've got IF address.
Oh,
Control C.
Try that again. My bad. It's a bad habit, right?
New muscle memory.
0. There we go. Hey, fantastic. So it got the 2.6 address, which again makes sense, right? Because we had excluded from 2.1 to 2.5. So I'm happy with that. And same thing with the IP rep list as well. It's got its default rep. So fantastic.
Awesome. All right. Well, thank you, Patrick, for this. I think you've done a really good job at helping all of our candidates as they're in their final stretch, their preparation for CCNA, understand the role of DHCP. We've seen that. We've seen it in action. We've done the configuration, the verification of the client. We just finished up the relay work. These are really important skills for your CCNA practice. So excellent job. So Rigo, come on back. Let's see how our final polls are, and then we'll tackle any kind of straggler questions we still got.
Absolutely, yeah. So for the 4th poll, I see that our audience did pretty well. So the overwhelming majority went with DHCP Discover and DHCP Requests. And those were our actual 2 top answers. So they got that right.
Good.
Yeah.
Fantastic. Well, that's awesome. All right. Well, we've got a couple of questions here, Patrick, that I'm interested in your perspective on, because I've been holding them for this point. So there was a question that came in. I'm trying to scroll and find it in our list to see if I can make sure I can call it out. But here it is. Just Boris asked, why is DHCP considered insecure? Insecure. So we could probably talk a lot about whether DHCP is considered insecure, but there are some security implications for DHCP. So what do we want to think about from a security perspective in DHCP?
I thought you were about to plug season 3, Hank. Season 3, which will be all about the security within the CCNA exam. So stay tuned for that. But yeah, I think the idea with DHCP being insecure is right. There's no authentication. There's no encryption of any kind here, and so one of the classic attacks, and you've probably heard of this as well, right, Hank, where a DHCP server gets overwhelmed, right? Or someone keeps just requesting address after address after address in the hope of starving the DHCP server. And the DHCP server is just happy to respond, right? It gets a discover message, gets a request message saying, hey, this is another MAC address. So a new MAC address must be a new device. So I'll just hand out another address and another address and another address. So I think I think that's what they're possibly getting at, Hank, with that question. And as I was saying, and as you hinted at for season 3, there are ways of protecting your network against that kind of specific attack.
Yeah, I think it goes back to some of the early. Remember, IPv4 and all these protocols like DHCP were designed and developed and engineered years and years and years ago. And I want to say it was a more innocent time in computers. It's not that we didn't expect security to be as big of a problem, but the initial users of the networks and the internet that was out there, they knew each other, right? There were researchers that were in there. And so building kind of an authentication based or encrypted based DHCP wasn't the focus at that time.
Yeah.
And DHCP is so fundamental just to bringing anything on, whether it's a mobile phone, a tablet, a new smart device, a camera. And so that's why DHCP itself lacks some of those security pieces, but there are these wraparound features, some of which we'll talk about in season 3, related to kind of bringing security in and building kind of a trusted network that you can protect your DHCP servers on that side. So definitely stay tuned for that, because those topics do have some relevance in CCNA.
I think the other classic attack that you're hinting at as well, I think, is where someone spoofs a DHCP server, right? Someone actually adds I was going to say an illegal DHCP server. It's not illegal. I mean, yes, but it's a not legitimate DHCP server, and kind of starts assigning IP addresses to devices within your network. So there's a bunch of things that we can do to protect our network.
Yeah. All right. I got one last question that I think is a good way to summarize and kind of bring together everything from our webinar before we hand it back to Rigo to kind of really close us down. And so we've got a question in here from Brian. How do we differentiate between a DHCP client, DHCP server, and DHCP relay? 3 important roles in DHCP. So if someone's trying to like hone in, right, give them the kind of the quick and dirty way to think about like what is a client versus server versus a relay in a network.
The client would be your phone, your laptop, the device that needs that IP address, right? So it's going to send out that discover message saying, hey, is there a server out here that can help me and give me an IP address? So the client is that end user device. The server is, as I just said, it's the device where we can configure the pool and start handing out IP addresses to these particular clients. The relay, it's like a go-between, right, Hank? How would you, I think
go-between is a great way to go through, right? Because DHCP is kind of built to operate on a single network, sometimes your server may not be on the same network as the client. And so the relay device is the one that kind of takes the message from the client and then relays it to the server for answering on that side. Right. So if you're trying to, when you're mentally picturing this, I'm a mental guy, an imagery kind of guy. That's the way I look at it, right? The client is the one needs something, the server has it, and then in between it, right, you've got that salesman, that person that's going to say, I can help you deliver this piece, right?
I've got your back.
Yeah, absolutely. Awesome. All right, Rigo, I think we're good. We've kicked off season 1 or season 2 here with some DHCP action. So back at you to kind of bring us home.
All right. Well, just want to give you both a very big thanks for this great session today. It's a great return to the prep series with DHCP. I appreciate you sharing your knowledge and expertise with our audience today. I hope that you all found great value in the information and resources that were shared here today, and that it is helpful with your exam studies. And I'd just like to cover a few quick items before we wrap up for today. We do have some CCNA prep resources for your convenience. And we just like to tell you a little bit more about those. So first, we have the CCNA Prep Learning Map that contains a curated list of resources that's designed to complement your core training and aid your learning experience. Then we have a prep practice quiz that offers a series of questions to test your knowledge on the topics. And we also have a free Cisco U tutorial on network services configuration for routers and switches, which will complement today's topic very well. So we highly, highly recommend that tutorial on the Cisco U channel. And as discussed earlier, we do have some activity files for Packet Tracer and also for CML to get some hands-on practice. And of course, we can't forget about the blueprint for the CCNA exam, which is the most important, and it's your main guide to help you prepare for the latest topics and what you need to learn before you can go ahead and take your exam. And again, you can make your way to these resources by scanning that QR code on your screen, but the link can also be found under your Slido resources as well. And next, I'd like to take just an opportunity to cover the upcoming sessions for for this series. So in this new season of the prep program, we have a total of 7 live events, and it includes this first session here. The next one is coming up in a little less than 2 weeks. That's going to be on February 11th. Hank Preston is going to be taking a deep dive into DNS. And this is actually going to be a special event because it's going to be broadcasted directly from Cisco Live in Amsterdam. And due to the time zone, we are going to have a special start time. So for the US folks, like for us on the West Coast, it's going to be very late or very early, depending on how you look at it. It might be at 1 a.m. Pacific time. But for Amsterdam local time, it's going to be at 10 a.m. But don't worry if you're not able to catch it due to your time zone. No worries, you can always catch it on demand at any time after the session completes. You can tune in to that session if you can, but otherwise we do have some other upcoming live streams as well. If you haven't done so already, you can register for the prep program to receive email reminders and easily add those sessions to your calendar. And you can also be notified when those recordings become available on demand. Lastly, we have launched a Slido survey, so we would really appreciate it if you can just take a moment to fill it out and share with us any thoughts or feedback that you may have about today's session. We always look forward to receiving your feedback, and we want to thank you again for joining us here. And thank you again to our presenters for this awesome session, and we hope to see you all for the next one in 2 weeks. And have a great day and take care. Bye, everyone.